Best regards to the best followers. Before starting, I would like to tell you that I'm proud of your work. The projects you sent concerning the history of discovering atom are amazing. I want to show you one of the best projects I've received. This project shows the model set by each scientist through the history of discovering the atom. Well, what are we going to learn today? Today we're going to differentiate between atomic number and mass number, explain how elements are organized in the periodic table, identify an element based on given information, atomic number, symbol, and location in the periodic table. Let's start. Do you remember the definition of element? An element is a substance composed of a single kind of atom. An element cannot be broken down into another substance by chemical or physical means. As an example, if I have oxygen, it cannot be broken into something simpler. Right now, what is a compound? A compound is a substance in which two or more different elements are chemically bounded together. As an example, we have water H2O, which is formed from two atoms of hydrogen chemically bounded with one atom of oxygen. What is a mixture? A mixture is formed from two or more substances that are mixed together, but are not chemically bounded. As an example, we have water which is mixed with salt in salt water. So the substance A, which is water, is mixed with substance B, which is salt, but there's no chemical bond between salt and water, and then salt is easily separated from water by evaporation. Right now, let's remember what we learned about atom. In an atom, the number of the protons is equal to the number of electrons, and then the number of positive charges is equal to the number of negative charges. When each positive charge is cancelled by a negative charge, an atom is a neutron. The atomic number is the number of protons, and the mass number is the number of protons plus the number of neutrons. For each element, a symbol, an atomic number Z, and a mass number A. Z is the atomic number, which is the number of protons. A is the mass number, which is the number of protons plus the number of neutrons. From these two values, I can find the number of neutrons, which is equal to the mass number minus atomic number, A minus Z. Let's apply what we learned. In front of me, the nucleus representation of sodium. Na is the symbol of sodium. 11 is its atomic number, Z. And 23 is its mass number, A. What may I know from these numbers? The atomic number is the number of protons inside the nucleus. As the atomic number is equal to 11, this means that there are 11 protons inside the nucleus of sodium. An atom is a neutron. As there are 11 protons inside the nucleus, there are 11 electrons in the electron cloud. How will I know the number of neutrons? The mass number A is the number of protons plus the number of neutrons. So the number of neutrons is equal to A minus Z. The mass number minus the atomic number. And then the number of neutrons is equal to 23 minus 11. And then there are 12 neutrons inside the nucleus of a sodium atom. Now it's your turn. Find the number of protons, electrons, and neutrons for each of the following elements. starting by Ca2040. Ca is the symbol of calcium, 20 is its atomic number Z, and 40 is its mass number A. What will I know from the atomic number? The atomic number tells that there are 20 protons inside the nucleus of calcium. As there are 20 protons inside the nucleus, there are 20 electrons in the electron cloud. And then the atom is a neutron. How will I find the number of neutrons? The number of neutrons is calculated from the formula N equal A minus Z. So N equal 40 minus 20. And then there are 20 neutrons inside the nucleus of calcium. Similarly for aluminum, Al1327. The atomic number Z is equal to 13 and the mass number A is equal to 27. The atomic number will tell that 13 protons exist in the nucleus of aluminum and then 13 electrons in the electron cloud. How will I find the number of neutrons? I'll apply the formula N equal A minus Z and then 27 minus 13 equal 14. Accordingly, there are 14 neutrons inside the nucleus of aluminum. What about fluorine F919? The atomic number Z is equal to 9 and the mass number A is equal to 19. How many protons do we have inside the nucleus of fluorine? The atomic number Z tells me that there are 9 protons inside the nucleus. As we have 9 protons inside the nucleus, there are 9 electrons in the electron cloud. The number of neutrons is equal to A minus Z. 19 minus 9 is equal to 10, and then there are 10 neutrons inside the nucleus. Always remember that an element is identified by its atomic number and then by the number of protons. If an atom contains 9 protons, this means that it's a fluorine atom. I'll never have a fluorine atom which contains 8 protons. If an atom contains 8 protons, this means that it's an oxygen atom. Have you ever heard about the periodic table? The periodic table is the most useful tool to a chemist. It organizes lots of information about the known elements. In front of me, a picture of the scientist Dmitri Mendeleev. He first organized the elements by arranging them in order of increasing atomic number. He observed that the properties of those elements were in a regularly repeating pattern. As we go from one row to another, they are the same properties which are repeating. Accordingly, elements with similar properties are positioned under each other. Mendeleev's arrangement of the elements became known as the periodic table. Look at the elements, how they are arranged in rows by increasing atomic number. The horizontal rows are called periods and are labeled from 1 to 7. The vertical columns are called groups and are labeled from 1 to 18. What may we know from each column? A group is a vertical column of elements from top to bottom. Elements in a group have similar chemical properties. For this reason, a group is called family. There are 18 columns in the periodic table. As all members of a family share the same properties, such as talking the same language, having the same nationality, belonging to the same country, elements of the same family share the same properties. As an example, all elements of column number 1 are very reactive with water. All of them are soft metals. But like everything in life, there are exceptions. In this case, hydrogen is an exception. Right now, what about the period? Each horizontal row of elements from left to right in the periodic table is called a period. Properties of elements in a row follow a repeating pattern as you move across a period. What information is contained in each square of the periodic table? Till now, we must be able to know the symbol, the atomic number, and the mass number of each element, and calculating the number of neutrons. Concerning the element shown in front of me, it's clear that CO is the symbol of cobalt. The atomic number Z is equal to 27, so it contains 27 protons in its nucleus and 27 electrons in the electron cloud. As for the number of neutrons, it's calculated by the formula N equal A minus Z. 59 minus 27 is equal to 32, and then cobalt atom contains 32 neutrons in its nucleus. What's the chemical symbol of chlorine? When we have two letters which stand as a symbol of one element, always the first letter must be capital and the second small. Accordingly, the right answer is the choice C. What is an element? If your answer is the choice C, you're correct. An element is a substance consisting of one type of atom. What are the only two elements in the first period of the periodic table? In order to know, I'm going to show you the periodic table, and then the first two elements in the first period are hydrogen and helium. True or false? In the periodic table, horizontal rows called groups and vertical columns are called periods. No, it's completely the opposite. Horizontal rows are called period and a vertical column is called group. The smallest unit of an element you can have is known as an atom. How many periods do we have in the periodic table? If your answer is 7, you're correct. In front of me, 3 elements: copper, oxygen, and silicon. Do you know what do they represent? They represent metals, nonmetals, and metalloids. In the periodic table, there's a zigzag line which divides the 3 major categories: the metal, nonmetals, and metalloids. Let's discover metals. Elements to the left of the zigzag line are metals, except for hydrogen. Metals are good conductors of heat and electricity. That's why copper is used in the electric wires to conduct electricity. And iron is used in stove to conduct heat to cook food. Metals are shiny. The best example of a shiny metal is gold. When I tell you metal, you'll think of iron, copper, silver, or gold. All of these metals are solids at room temperature. Mercury, the substance used in thermometers, is the only liquid metal at room temperature. Most metals are hard, but for sure the hardness differs from one metal to another. As an example, iron is so hard, but sodium is soft. You can cut sodium with a knife. All metals are ductile. Do you know what I mean by ductile? Metals can be stretched into thin wires. The copper wires used to conduct electricity was originally like a rock, and then they transformed into a wire. This property is called ductility. Metals are malleable. They can be flattened into thin sheets, like the aluminum foil which you use in your kitchen. The elements which are at the right side of the periodic table are non-metal and have properties completely opposite to metals. If metals are good conductors, non-metals are poor conductors of heat and electricity. If I try to flatten a piece of carbon, it will be broken. Accordingly, nonmetals are neither ductile nor malleable. A piece of charcoal don't shine, and then nonmetals are dull. As we arranged before, metals are shiny like gold, while nonmetals are dull like carbon. Metals are used to conduct heat and electricity, while nonmetals are poor conductors. We need a high temperature to melt iron, so metals have high melting points, but nonmetals have low melting points. I'm able to flatten aluminum into a foil, so metals are malleable, but carbon will break if I'll hammer it, so nonmetals are brittle. All metals are solids except mercury, while most of nonmetals are gases such as helium and neon. Elements which border the zigzag line are called metalloids. The metalloid which we're familiar with the most is silicon. Elements classified as metalloids have physical properties of both metals and nonmetals. Some are shiny, some are dull. They are somewhat malleable and ductile and can conduct heat and electricity to a lower extent. Accordingly, metalloids are called semiconductors. They conduct just the right amount of electricity or heat. That's why they are used in electronics such as radio, computers, or telephones. Right now, I leave you with this quick challenge. I'm waiting for your answers. As an optional activity, create a poster of the periodic table. Show how the elements are organized into metals, nonmetals, and metalloids.